Hello, and welcome to the IoT Chat, where we explore the latest development in the Internet of Things. I'm your host, Christina Cardoza, editorial director of Inside.Tech. And today we're talking about the evolution of cancer research and treatment thanks to advancements with AI with Dr. Johannes Uhlig from UMG in Göttingen, Germany, and Dr. André Aichert from Siemens Healthineers. So excited to jump into this conversation today, but would love to learn a little bit more about our guests. So André, I'll start with you. Please tell us more about yourself and your role at Siemens Healthineers.
Yeah, it's a pleasure to be here. So my name is André Aichert. So I'm a research scientist at the Artificial Intelligence Germany Department of Digital Technology and Innovation at Siemens Healthineers. And my background is computer science with a focus on, let's say, medical imaging, image processing, computer vision, and artificial intelligence. So I was excited about images and graphics for a long time, even as a kid. And during my studies, I found that actually the analysis of images has a lot more relevant and challenging issues than just the generation of graphics. So that's why I went into this direction. And as I was looking for an application for the things I was learning at university, the medical field just seemed very attractive because it has a lot to offer. It's a great choice because it has a lot of data, a lot of problems to be solved, and it also seems generally beneficial to society. So that's what motivated me. And Siemens Healthineers as a company was very attractive because it builds about a quarter of the medical imaging devices worldwide. So it's a really great opportunity to find problems and solve them, and that's why I joined DTI as a researcher after my PhD. And we just have a wide range of researchers for all sorts of fields, modalities in medical imaging and artificial intelligence. And it's an exciting environment to be in. Yeah, we bring together a lot of the technology, hardware processes and all for AI. So that's what we call the AI factory. And that's why it's absolutely the right place to be if you want to do research in this direction.
Excited to dig more into that. But Dr. Uhlig, let's get you in here. Please tell us more about yourself. What is UMG and what you do there? And also, what your relation is to Siemens Healthineers.
Absolutely, Christina. Thank you so much for having me. It's a great pleasure for me. So my name is Johannes Uhlig, and I'm assistant professor of radiology at the University Medical Center in Germany, in central Germany. So throughout my medical studies in Germany, I have been really interested in clinical cancer research. I've worked side jobs at the German Cochrane Center and even the thoracic surgery department at my university. And following this, real passion, I completed a Master of Public Health program with concentration in biostatistics and epidemiology at Harvard University after my med studies. So I started my residency in radiology in 2016 because this, for me, really is the medical subspecialty that serves as the most crucial gatekeeper for all relevant clinical decision-making, being it emergency medicine, trauma care, cancer diagnosis, treatment response assessment, or minimally invasive cancer treatment. And what really drives me is employing my background in biostatistics and epidemiology and combining this with my passion for radiology to ultimately improve clinical patient care. I'm not a full-time researcher, but I'm rather a clinical radiologist with a really strong research background. And so since 2019, I'm heading the AI research group at our Department of Radiology at UMG. And since my wife and co-head of the research group is a urologist, we mainly focus on urology cancer research, including kidney cancer, bladder cancer, prostate cancer. So far, we have employed AI models for cancer detection and assessment in various settings, and we recruit several hundred patients each year for our ongoing studies. We currently also apply our research expertise to other cancer types. So our Department of Radiology has a very strong and lasting relationship with the Siemens Healthineers. We mainly rely on Siemens scanners in our whole department, and we have completed several research projects in the past.
Great. It sounds like this is, something that's very passionate to both of you. And I think that's very important when you're dealing, especially with this type of, research and, really to find the opportunities and make it beneficial to doctors and patients out there. So I want to start off the conversation just looking, getting the state of, cancer research and cancer care today. And André, I'll pose this question to you first. What are the advancements you've seen in AI that have really been transforming this space for both doctors, researchers, and patients?
Yeah, I mean, the impact of AI to the entire healthcare space cannot be understated. So I'm sure there are lots of examples in this domain. I mean, as a company, we've been around pretty much since the first X-rays were taken, and we've been improving detail and also the amount of images ever since. So I believe that at the moment, the most important use of AI would be to give clinicians and our customers the opportunity to actually deal with this vast amount of images and vast amount of data, and to support them in getting the most out of it. But certainly, like everywhere else in the healthcare space where data is available, which is basically everything, there would be AI solutions that could be added to this. So I'm looking at this from an imaging direction, but this certainly doesn't mean that it would be limited to that. So I think that generally I say AI solutions, they're essential. And I guess clinicians that start using them today and are at the state of the art of the technology, they'll have the advantages, and it'll give them a lot of power in this sense. As for the Cancer Scout project, which is why we've been incorporating with UMG Göttingen now in my particular project, there we're actually analyzing a host of different data sources. So it's not just images, actually. We work with the pathology department there to analyze sections of tissue under the microscope, but also we have omics data, so genomics, and also proteomic data. And in all of that, we try to define subtypes of cancer and also to detect them and sort of figure out which subtypes we can actually see in the images, so that we perhaps do not need to look at the proteomic data, for example, which is a lot more unusual and difficult to obtain. So this project is actually a 10 million euro project that's mostly placed at Göttingen. So we work on a relatively small part of that for the data analysis and also the image analysis specifically. And we're trying to just define subgroups that make sense. That's basically the goal of this. So for the radiology sub-project of it, which is where Dr. Uhlig comes in, we actually have a slightly different setup, because there the radiology images are supposed to be the original source of images, and there you can detect nodules already in CT images. And then the question is, can we also recognize certain subtypes already based on these radiologic images, which then would not require, for example, a biopsy, like an invasive biopsy, to actually be done. And that's I think where this is going. So trying to optimize workflows, trying to prevent unnecessary invasive procedures, and data analysis of all sorts.
Absolutely. I love hearing projects like that where, you're teaming up with a bunch of experts from, different areas to really, make a change and make an impact, to, see the challenges and start creating solutions around them. And so, Dr. Uhlig, I'd love to hear from a cancer research and a clinical perspective, what the benefit from you guys of being part of this project has been, as well as the opportunities that you have been seeing with AI-based healthcare solutions in this space.
Absolutely. So from my perspective, there are several current challenges in clinical cancer imaging. For example, we see demographic changes with an aging population in most countries and associated increase in healthcare needs. Additionally, radiology imaging has seen technical advancements over the last decades, and it's more broadly available and more frequently used than maybe 20 years ago. For cancer imaging in particular, we face a massive increase in case numbers, and I believe that can't be assessed by radiologists in a traditional way, let's call it that way. For example, breast cancer screening in Germany. We used X-ray-based mammography, which is recommended biannually for women aged 50 to 69. And the most recent data, it's coming from 2018, reports that 2.8 million women got a mammography. and 97% of these scans were negative scans. And the current setup is that every mammography has to be independently assessed by 2 experienced radiologists. And at the same time, we have literature suggesting that AI-based methods for mammography assessment are at least comparable in their diagnostic accuracy to radiologists. So these AI algorithms really provide a standardized and reproducible second reading for mammographies. Now the question that comes into mind is, can we use these AI algorithms instead of the second radiologist, or is it even imperative to implement these AI algorithms in a setting from both an ethical and economical standpoint? And I believe breast cancer screening is only the tip of the iceberg. At least in Germany, we will probably see other cancer screening programs like a low-dose chest CT, and these will put further strains on our clinical imaging community. And I strongly believe that AI algorithms will support radiologists within this decade, for example, for standardized cancer imaging. As going for cancer research, I believe AI is kind of the buzzword for the last decade, and a lot of excellent research has been published. In particular, AI algorithms are used for assessment of cross-sectional imaging, such as CT or MRI. For example, our research group has so far focused on extracting additional information from CT and MRI images to guide clinical decision-making in patients with suspected kidney or prostate cancer. And now in the cooperation project with Siemens Healthineers and the Department of Pathology here at UMG, we use AI algorithms to correlate radiology CT imaging of lung cancer patients with a pathological analysis in a large-scale cohort. And for that, we're using the SingoVia software, as aforementioned, this large cancer scout project. And we hope that one day these AI algorithms will advance the role of radiology imaging in guiding lung cancer treatment.
Absolutely. I know, a lot of people in the medical field, they are, overworked. There's a lot going on. And across the, entire IoT space, I see just a lack of skills out there. So, bringing AI in, making it stable and, having the confidence that it can actually help, make diagnosis or, advance this research, it sounds great because it's going to take some of the strain off of the medical industry, but also, give more confidence in the patients when they get and receive their care. André, I'm wondering, I saw on Siemens that you guys have a research platform, and I know this is probably just one small piece of the puzzle to this larger cancer research, project and efforts out there. But I would love to hear a little bit more of the SingoVia Frontier research platform, how this fits in your efforts, what the pain points this is trying to solve, and, how research platforms like this and how bringing AI in, really compares to the traditional way of doing things.
Yeah, I think to answer the question, I would have to explain some of the specific practical problems if you want to do research in the clinical environment, first of all. So we're dealing with personal information before all, right? So you have to be very careful about, for example, GDPR in Europe or HIPAA in the US. So special care has to be taken about that. And that also means that just accessing data and getting to the point where you have the basis for AI algorithms is a much bigger process, or sometimes a bit more difficult than you'd imagine. And there are practical problems associated to that as well. So still to this day, most of the successful AI algorithms are actually supervised. That means you need also to collaborate with the clinicians to actually give you annotations and give you an idea of what you're actually looking at for an AI algorithm to then reproduce these findings, so to say. And therefore, it's critical to actually get the access to this data and to also to create those annotations. And then if you look at the clinical landscape, the IT landscape is actually scattered. It's not just between different vendors and departments or even sites if you want to do large scale research, but also it has organically grown over decades. And sometimes these systems, they do not communicate in the way that maybe you'd expect from, today, your phone. And in order to collect and harmonize the data from these systems is actually a lot of work and can be very painful at times. So for example, if you have like your favorite program on GitHub that is free to use and you just want to run it over some data, that can actually be a process at the clinic. You want to make sure that, first of all, the data that you're using it with is anonymized. To access the data, you typically go to, say, if it's image data, to your PACS. You anonymize, export it, copy it over to a different computer where you're running the software. Then you have to make sure that it actually is anonymized. Otherwise, if there is like a risk of re-identification, you kind of have to make sure that you're even able or allowed to use that software. Then you kind of get your results. But if you want to take them back, you also have to go back to the original system and reintegrate them, potentially even with additional information from other IT systems. So this is very different from, what I'm used to as a researcher or as an actually user of IT in my daily, business, so to say. It's a challenge sometimes. And then even if you've trained your first models and you want to test it on real-world data, that can also be a problem, because then you have to kind of find a way to get the initial prototypes back to the clinic and run them. And that's actually a challenge that I'm currently facing also in other projects, that there is a very long process of actually releasing such a prototype to make sure it's safe. You have all sorts of licensing issues. For example, a modern web application, it is a very complex tool chain associated to building a website, for example, if you're using anything like that in your platform. You have to make sure that cybersecurity is okay and all of these things. So basically, in all of the things that I just explained, the Single Frontier platform, research platform, sort of tries to help in all of these steps along the way. It's an end-to-end integrated solution. So basically, it is running at the clinic. If you have a single VIA installation, basically, it's free to use. And it uses all the existing infrastructure, so to say, that you can run it on the data that's available in your PACS. You can download applications from a marketplace that exists in that system that has third-party and also Siemens applications that you can use, research applications. For example, that's what we did for Cancer Scout for the annotation process. And because it is sort of using all the infrastructure that's already in place, also the installation of it basically means a similar effort to updating the existing software. You just have to briefly connect to the internet, download the application, you can use it. And that is a very, very big advantage over just, getting your own software and trying to integrate it somehow with the process that I described earlier. And thinking further into the deployment of the first prototypes, it becomes even more important because as I described, the process of releasing such a prototype to the clinic is actually a long one. And you're running the risk of, having your development team working on a clinical use case, developing beautiful software before they go through the effort of actually releasing it to the clinicians and then trying it in the real world. And then all of a sudden you start realizing that there was a very basic assumption that was not exactly what it should be in practice. And then you got a problem. And what you want to do is in the Silicon Valley, guys should be familiar with it, is to fail fast. And that is actually meaning that you want to be able to sort of have an early prototype that probably doesn't exactly solve the problem yet, but bring it to the clinician, get feedback, and sort of shorten this feedback loop. And that is also one thing where Single VIA Frontier certainly helps.
Yeah, I love that idea of fail fast. I think when people are doing things like this, it's always a worry that you are going to fail, but that helps, you improve and, continuously learn. And that's part of the process, and that's important. I also love that you brought up data privacy in the beginning, because everybody wants to know how their data is being protected, especially when it comes to medical and healthcare data. It becomes even more sensitive. So it's great to see that that's something top of mind for Siemens Healthineers in all of this. Dr. Uhlig, I want to hear from your perspective, just being part of this Cancer Scout program and also, the importance of this Single VIA Frontier platform. How did you hear about Siemens Healthineers? How did you guys come together to start working on this? And how have you been utilizing their research platform for your own research and clinical purposes?
Absolutely. So at our Department of Radiology, the Single VIA software, the clinical software, is deeply embedded in our clinical workflow. For example, we use the Single VIA software for all cardiac CT scans, for coronary vessel identification, or as an on-the-fly image viewer and reconstruction software in trauma patients. So based on my personal experience over the last several years, the Single VIA software really robustly performs in these scenarios. There's rarely a case where I have to redefine coronary vessels And even in a time-critical setting, such as trauma care, the software robustly supports my clinical needs. And so when we had the chance to collaborate with Siemens Healthineers in the Department of Pathology at UMG, there was really a low threshold for us to use the Singovia software for data accrual, annotation, and supervision. Just to give you a perspective, we had 4 researchers working on this project, on the Cancer Scout project, for several months in full time. We had several thousand patients, and the project had to run smoothly with all these people and all these patients. And for me as a radiologist, it's crucial to have something I want to call a one-stop shop. I want to use as few software tools as possible for my whole data pipeline. And indeed, the Singovia Research Frontier, the plugin for the clinical software we're using, is an excellent choice to my end. To go a little bit into detail, with the Singovia, we have one software and we can extract data from our imaging database. It's easy because it's already clinically embedded and we can use it as a research tool. We can annotate cross-sectional images, and we can anonymize these cases in a setting that is compliant with the strict German regulations and laws. Surely there are some areas where Singovia Research Frontier software could be optimized, such as the graphic user interface or the ease of data management in larger studies. But from our experience in this project, I really believe that Singovia is an excellent software for at least our specific research needs, and we will continue to use it in other projects in the near future.
So one thing that seems clear throughout this conversation is, there are many opportunities out there, and it's not something that one single organization can do alone. It really takes an ecosystem, and partnerships to find those opportunities and really start solving these real world challenges and use cases. And I should mention, the IoT chat as a whole and Insight.tech, we're sponsored by Intel. So, André, I'd love to learn from a Siemens Healthineers perspective what the importance has been about working with the university on this project, as well as what the value of your partnership with Intel and that technology in all of this.
This is completely right. Exactly, Christina. I cannot agree more. So cooperation is absolutely essential. So if we didn't have researchers, clinical researchers like Dr. Uhlig, who are willing to cooperate with us and share their knowledge and their understanding, also explain the problems that they have, then it would be very hard for us to do any progress in this field. And this doesn't go just to one department at the clinic. Actually, you have to look at pathology. You have to look at certainly the oncology department. You have to look at radiology. You have to integrate all sorts of other departments from the clinic. Say, if you were doing prostate cancer, then certainly you'd want to have a urologist available. And communication is absolutely key here. And as a AI researcher, certainly the learnings that we take for all the use cases and the clinical routine, that's absolutely essential for us to address the right problems in the right way. So to sort of produce an actual technical solution, first of all, as an AI researcher, I also have to understand a little bit of the clinical problem at hand. So this is absolutely essential. And also a lot of the questions cannot be answered by one party alone. For example, if we are discussing with Dr. Uhlig which software do we want to use for the annotation, then it doesn't suffice for us to understand what sort of data format we need out of this process so that we can work with it with our models, say. But it's just as important that for example, the usage of the software corresponds to what they do in the clinical routine, that the presentation of the data is in such a way that, a physician can actually tell sort of types apart or tell locations and geometry apart. And then sort of you have to come together and actually define a annotation protocol that makes sense. And for us, the cooperation with UMG in particular was very, very pleasant in that regard. I just cannot stress enough how important it is to have this cooperation and to have this conversation in order to prevent a disconnect of technology and application in this domain.
Absolutely. And, when you're talking about making sure you have the data available and you're able to analyze it, all of the training and model development that you have to do, and this requires a lot of speed and performance. I assume that's where Intel is coming in with their software kit, like the OpenVINO software kit, and also the processors that they have available. Has that been beneficial to the university and to this project and Siemens?
Arguably, I've only talked about the creation and the research of the AI models, but in order to actually create value, obviously, you'd have to use it in the clinic on real patients. And at that point, the typical clinical workstation would be running on an Intel processor, and that's really where then finally people would have a benefit from the hard work that we've been doing before. So that's definitely where we'd come in.
Great. And Dr. Uhlig, you mentioned, this is really just hitting the tip of the iceberg. There are many different types of, cancer out there, many different facets that go into cancer research, many different people and organizations and just fields that you can break off into this. So I'm wondering, what do you envision for the future of this project, your collaborations and, cancer research?
Yeah, absolutely. So the Cancer Scout project is ongoing as we speak. And I think there's really much more to be done. In particular, given my background as a clinical radiologist, I strongly believe that it's crucial to assess these AI algorithms we build and train in a clinical setting. So basically, it has to work. It has to work in on suboptimal scans where the quality is not perfect. It has to really work robustly with different scanner types, different patients. And this is not only like this testing process is not only including the accuracy of the AI algorithm, but also the acceptance by radiologists and clinicians. For example, how do we best present the AI results? How do we visualize these? And how do we confer the associated uncertainties or report outliers? But I guess given the mutual trust that was earned throughout the productive cooperation within the scope of this project, I believe that UMG and Siemens Healthineers as partners will find ways to address these challenges and also opportunities.
Absolutely. Lots still to be done. So André, from a Siemens Healthineers perspective, what do you envision from, the future of cancer research and, your collaboration and ongoing projects?
Yeah, definitely. I mean, I can only agree with Dr. Uhlig. And one of the essential next steps for the models that we produce there would certainly be to look at other sites. So scalability is key in this regard. And we've already used a solution called TeamPlay to collect the data from UMG, and that could also be used to collect data from other sites that have been produced in a similar manner. And that is basically what allows us to also integrate or to also support different IT infrastructures in different locations, which may be very different from what UMG is doing. And the other thing is basically that I would like to mention for AI. You should be careful with overreached expectations, because actually there's a lot of work to be done in this domain. If you want to, optimize the last few percents of performance, which is very relevant in the medical domain, because it basically goes down to, patients who are these few percents and who then get a correct or not correct diagnosis, then you have to really put a lot of work in, and you're in for the long haul of improving these models and having this feedback loop that we discussed earlier. So certainly platforms like Frontier also support us in this iterative process and also integrate other centers in this.
That's a great point. AI it's great. There's been many advancements and there's many opportunities and benefits that come along with it. But especially in, a research project like cancer research, be aware of what AI can actually do, and like you said, set your expectations. I can't wait to see what else comes out of, these ongoing collaborations. Unfortunately, we are running out of time, but before we go, I just want to throw it back to each of you one more time for any final thoughts or key takeaways you want to leave our listeners with today. So, André, I'll start with you again.
basically the takeaway messages for me would be that the medical domain is a really exciting field for AI researchers that I can only recommend because you have this very diverse set of problems, very diverse set of modalities and images and also other electronic health records that you can work with. And it actually is very beneficial to look at this field. And also it's very exciting to, share knowledge and to also see other people work, like, for example, at the clinic. It's very, very exciting field, and you always keep learning new things. And then, obviously, for the practical part, you kind of need, platforms, research platforms that support this life cycle that basically we've discussed over this podcast, and that you want to be able to share knowledge and data, but also drive collaboration in all sorts of medical disciplines, supporting this iterative process and ultimately develop and deploy applications. So that would be my takeaway.
Great. Dr. Uhlig, anything else you'd like to add?
Yeah, absolutely. I can agree with André on almost all these talking points. And I just want to stress that for me as a clinician, I believe AI really is the future. I guess there's no way that we're going to work without application of AI algorithms within the next 10 years, just given the caseload, given the economical stress we have. And also I have to underline that AI research really is a team effort. And we really need these collaborations between academic institutions like UMG and manufacturers like Siemens Healthineers to advance healthcare, especially given what is at stake in cancer imaging. And only through this ongoing mutual feedback, adjustment, and fine-tuning, I believe we will create AI tools that are not only accurate, but also accepted by healthcare professionals.
Absolutely. I love that this takes a team. And so, I can't wait to see, what else comes out of all of this. And I'm excited to learn more, so thank you again for the insightful conversation and joining us today. I would invite all of our listeners to, visit the Siemens Healthineers website as well as the UMG website where Dr. Uhlig is from, so that you can learn more and keep, up to date with their progress on the research project. So thank you both for joining us today, and thank you for our listeners for tuning in. Until next time, this has been the IoT Chat.